This is an assembly guide for the Open Wave Height Logger Revision C hardware. The drill template in the lower right can be ignored in most instances. Start by placing the solder paste stencil over the CPU board. Line up the cutouts of the stencil with the component pads on the board. Apply solder paste to the top of the stencil and use a credit card or similar tool to smear the paste into the stencil openings. This should leave nicely applied solder paste blobs on each pad on the board. You could also do this manually using the solder paste syringe tip if you do not have a stencil. The first chip we'll place is the ATmega 328P microcontroller. There's a black dot on top of the chip that should be matched up with the white dot on the pattern on the circuit board. Next, place the 10,000 ohm resistors at positions R1, R2, R3, and R4. Orientation does not matter here, just make sure that both ends of the resistor are each touching one of the solder paste pads. Place the 1000 ohm resistors at pads R9 and R10. Again, the orientation of the resistors does not matter here. Place the real-time clock chip. This chip has a notch on one end, which should be oriented so that it points to the same end as the white dot on the circuit board pattern. Place the transistor on the pads labeled BJT. This can only be oriented in one way so that it matches up with the circuit board pads. Place 0.1 microfarad capacitors on pads C1, C2, and C3. Orientation does not matter here, just make sure that the capacitor ends are each touching a solder pad. Position the reed switch. Orientation does not matter here either. Begin preparing the power circuit board. Position the stencil and apply solder paste to the circuit board pads. Place electrolytic capacitors at position C3 and C4. Orientation does matter here, so match up the capacitor shape with the pattern on the circuit board. Install the JST PH series battery connector. Updated versions of this circuit board will have two holes for directly soldering your own battery wires if you don't want to use JST connectors. Place the voltage regulator. The legs should match up with the pads on the board. Place a 0.1 microfarad capacitor at position C2. Orientation does not matter here. Place a 22 microfarad capacitor at position C1. Orient the capacitor so that the white bar is closest to where the microSD card holder will be. Place the green LED on the pad labeled LED 2. There are green marks on one end of the LED that should be oriented away from the plus marking on the board pattern. The same is true for the red LED. Orient the green mark on the red LED so that it points away from the plus sign on the board. Place 510 ohm resistors on pads R7 and R8. Orientation does not matter here. Place the push buttons, which are also known as tactile switches. Orientation does not matter here, just match up the legs with the pattern on the board. Install the 100,000 ohm resistors at pads R1 and R2. Orientation does not matter. Now install the pressure sensor on the MS5803 board. The sensor itself comes with solder on its pads already, so you don't need to add solder to the circuit board. Instead, apply a small amount of liquid or paste flux to the circuit board. Orient the MS5803 sensor so that the blue dot in the corner of the sensor matches the white dot on the circuit board in the lower right of the image here. All three circuit boards are ready to solder now. We use a toaster oven as a reflow oven to melt the solder. The peak oven temperature should not exceed 235 degrees Celsius. After soldering in the oven, we need to add the remaining parts. On the pressure sensor board backside, solder a 0.1 microfarad capacitor on pad C5. Here I use a soldering iron and solder paste. On the pressure sensor board, install the female headers into the receptacles, pointing down away from the pressure sensor. Solder each pin in place with a soldering iron and solder wire. On the CPU board backside, add solder to the center pad of the backup battery pattern. Next, install the backup battery holder by soldering the two sides of the holder to the pads on the board. This holds a CR1220 sized lithium battery to run the real-time clock. On the CPU board backside, also add the piezo buzzer by soldering its pads to the board. Orientation does not matter here. Add the 2x3 header for the programmer on the CPU board, with the pins pointing towards the top side of the board and soldering on the back side of the board. This header is used to burn the bootloader program onto the microcontroller in a later step. Install the long lead wire wrap headers on the CPU board with the long pins pointing to the top side of the board, and then solder in place using a soldering iron. Similarly, on the power board, install the long wire wrap headers with pins pointing towards the top side of the board and solder them in place. This finishes the soldering assembly of the three circuit boards. Now take the CPU board by itself and attach the AVR programmer cable to the 2x3 pin header. Orientation matters here. The AVR programmer plug should have an arrow or mark on pin 1, which is the MISO line that is marked on the CPU circuit board. Power needs to be supplied to the microcontroller while burning the bootloader program, so we also switch on the power target switch on the programmer. To upload to the OWHL, we first need to install a bootloader program. Find the OptiBoot repository on github.com, scroll down and you'll find a link to the OptiBoot release page. On the release page, copy the link for the JSON file. Now switch to the Arduino software, go to the Preferences page. In the Additional Boards Manager's URL field, paste the link that you copied from the OptiBoot GitHub page. Click OK, and now go to the Arduino Tools Boards Board Manager menu item. The Boards Manager window should open, and you can search for OptiBoot. Click on the Install button for OptiBoot, and then click the Close button. Now when you go to the Tools Boards menu, you should see a listing for OptiBoot on 32-pin CPUs. Click on that entry. Now go back to the Tools menu, and you should find a new entry for CPU speed, and choose 8 MHz internal instead of the default 16 MHz. Also go to the Tools Processor menu item and make sure that ATmega 328P is selected. With the programmer hooked up and OptiBoot installed, we can now burn a bootloader to the OWHL. First, ensure that you have chosen the correct target board, with OptiBoot on 32-pin CPUs, 8 MHz internal speed, and ATmega 328P processor. For my AVR Pocket programmer, I choose USB Tiny ISP from the Tools Programmer menu, and then I can choose Burn Bootloader at the bottom of the tool menu. Now attach the FTDI USB adapter between your computer and the OWHL's FTDI 1x6 header. Orientation matters here, so match up the markings on the FTDI board with the labels on the OWHL board. Black ground are labeled on one end of the header, and the opposite end is labeled DTR. Now we will upload the setTimeSerial.ino program to the OWHL. This will allow you to program the onboard real-time clock, and the backup battery will ensure that the clock continues to run even after you remove the other power sources. After the upload completes, open the Arduino serial monitor. This will show you the clock's current time and let you enter a new time in the prescribed format. Here, I will use an online UTC time zone clock to tell me the current date and time. After typing in the date, followed by the time, with spaces in between each value, hit Enter to upload the time to the real-time clock. If you mess up, you can always re-enter the date and time again. Either before or after you upload the main OWHL.ino program, reassemble the 3 circuit boards and install a microSD card so that the OWHL can start collecting data. With the clock now set, upload the main OWHL.ino program. This is the program that logs the pressure and temperature data. After uploading, it starts collecting data automatically whenever power is applied from either the FTDI adapter or the main battery pack. After you complete the upload with the FTDI adapter still attached, you can open the Arduino serial monitor window and see the output of the OWHL program. This completes the assembly of the OWHL circuit. When programmed with the main OWHL.ino program, 2 error codes will notify the user when data collection cannot start. If the real-time clock is not set or the CR1220 backup battery has failed, the OWHL will light the red LED, and the green LED will flash slowly and continuously while a chime sounds. If this occurs, check the backup battery and try reprogramming the real-time clock by uploading the setTimeSerial.ino program as described earlier. If the microSD card is not installed, or otherwise unreadable by the OWHL, the red and green LEDs will flash continuously and a fast chime will sound. If this occurs, install a working microSD card and reset the OWHL.